You know, when you talk about energy levels, you're talking about a nucleus around which you will have electrons revolving around, right? If you remember that, I've explained a Rutherford atomic model, which I will explain again, no worries. It's just to explain you the energy level. What Rutherford is saying, as per the test record, what he had it, he said it that there is a small nucleus in the center in which you have protons and neutrons having strong nuclear forces and everything, and electros. I mean, what do you call it? Electrostatic, attraction and everything in that. So this is your positive charge around, and electrons are revolving in the shells. These are electrons. Now, my question to you is, Zohar, an electron which is nearer to the nucleus, what do you think? It has a strong force of attraction towards the positive charge, means nucleus. Am I right?
Yes.
And the electrons which are far away from the nucleus, they have less force of attraction between the nucleus and electrons.
Yes.
Good. Now, the same thing. There is a guy who is just a subordinate of Rutherford, actually. His name is Neil Bohr. He proposed something interesting, and he actually modified Rutherford model. He said that electrons are not actually revolving in the shells, but they are revolving in energy levels. Each shell, he called it energy level. Okay. So this is one energy level, this is another energy level, this is another energy level, and there are further shells, then definitely those are other energy levels. Now, what he said is, you tell me which electron got more energy in the first shell, in the second shell, or in the third shell?
In the first shell.
In the first shell. Okay. Now, my question is, if you want to remove the electron, let's suppose if you want to ionize the atom, now I'm using a word ionized. When I say ionizing, it means to remove the electrons. I have to apply some energy or I have to give some energy. Am I right?
Yeah.
Shall I have to give more energy to this electron or that electron? The last shell one or the first shell one?
The last shell.
Last shell. Fine. For example, if I applied the energy equivalent to the first shell one. Okay. So my question to you is, what do you think? That electron will jump out of the first shell directly? Or will it come to the second shell, then third shell, and then getting out of the atom?
I think it will go to the second, third, and then jump out.
Absolutely. So when you think, if I call this shell as an energy level, when it jumps, no, again, this is higher energy level, this is lower energy level, and this is further lower energy level. What do you think when electron jump from higher energy level to the lower energy level? Do you think it will release certain energy?
Yeah.
And that energy can be given as E is equal to HF.
So energy is lost.
Energy is lost in the form of what? Frequency. And when you say frequency, it means color. You know the question you have asked me I think 1 or 2 weeks before in the Ramadan. It's related to energy level thing. So basically, what happened when electron jump from one energy level to another energy level, it liberates energy or it releases energy, and that energy can be given by E is equal to H frequency. So that frequency means it's some sort of wave spectrum or frequency spectrum. Now it depends. There are different energy levels. So there may be different type of light energies, or depending upon there may be different energy, which I will definitely explain to you. But do you understand that? The basic theme of it?
Yes.
Now I want
Yes.
you to understand few terms related to that. These are the terms which are very, very important and you should know it. First thing is called as ionization. Now, what do you mean by ionization?
The splitting of atoms.
No, 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 no,
Mm.
not splitting of atom. It is called removal, addition of an electron from or to the atom. Actually,
Oh,
when
yes.
when you say this is an atom, let's suppose, right? An electron is here. Now, an atom is technically neutral. It means number of protons are equivalent to the number of electrons. Now, when you ionize it, it means you knock out the electrons or you penetrate more electron into this. So what happened? The what you call it, the number of electrons and the number of proton ratio will be disturbed. And when you disturb it, you are actually ionizing it and it becomes an ion. So it's written as the removal or addition of an electron from or to an atom when giving sufficient energy is called as ionization, right? And there is another word which you have seen here is called as excitation. When an electron is given enough energy to move up on an energy level, but not enough to leave that. Now, what does it mean actually? Like, for example, this is your electron. This is your electron here. You provide enough energy to this electron so that it jump from this to this energy level or this to this energy level, but it didn't leave the energy. So we called it excitation. Ionization means you remove it. Excitation means you didn't remove it, but you try to remove it. The energy you provide is not 101% fulfilling the demand, so that it just changing the energy level. Maybe it jumped from first energy level to the second energy level. That's what we called as excitation. I want you to.
So
Mhm.
ionization is just the complete process.
Yes, ionization simple means you remove electron. You provide enough energy so that electrons will be removed. Okay. So electrons will be removed in this, while on the other side, excitation simple means that you excite the electron. Excitation means it jumps from one energy level to another energy level. Sometime what happened? It jumps from greater to the lower energy level. Sometime it jumps from lower to higher energy level. But excitation generally means you provided more energy so that it will jump slowly from higher to the lower energy level, because you actually break it. You are providing energy so that it will excite, right? So I want you to, can you quickly write that, please? You wrote it. Now let's check this. Now check this out. There is an experiment which they have done it. Now what experiment is saying? The one which you have talked about it. Fluorescence occur when an electron is in atomic orbit, absorb energy from an interaction with a photon or collision with an other atom. Fluorescent tubes are partially evacuated glass tube filled with a lower pressure mercury vapors with a phosphorus coating to the ground. Now, what exactly is this whole scenario is? Let me explain it to you. This is the whole equipment, right? In this whole equipment, fluorescence occur when the electron in an atomic orbit absorb energy from an interaction with the photon. Now, important thing is when it absorb photon, what does it mean? You are providing energy to the electron and energy start jumping from one energy level to another energy level. That's what it means. So basically, if you check this out, this is a sort of a tube, this is an electric tube. This whole is a basically fluorescent phosphorus coating screen. I mean, you can say this is a tube light in your house. And this screen, which you can see here, this one, that is simple glass, or you can say a phosphorus coated glass in this. Now, what happened? This is your cathode through which the electrons are emitted out. Now, what happened? As the electrons are emitted, okay, they've been provided photons, or you can say they've been provided energy. So, what happened? They start jumping from one energy level to another energy level. So, fluorescent tubes are partially evacuated glass tube filled with low pressure mercury vapors, which phosphorus coated on the glass. When the electric current is passes through the vapor, the electron in the mercury are excited and move to higher energy level. Now, this is interesting actually. These are electrons here. When electrons are excited, they get energy, they jump to the higher energy level. Then this get energy, they get to the higher energy level. The point is when it gets into the higher energy level, what actually is happening in this? So electron in a mercury are excited and move to the higher energy level. The higher energy level state is unstable, so electron moves back to its original state or de-excite. Initially, they get the energy, they jump to the new energy level, but of course, it will not sustain that energy, the new energy level, energy for a very long period of time. So it jumps back. When it jumps back, what will happen? And de-excites an electron release some of that energy in the form of UV photon. What is UV photon? E is equal to H frequency. So now what is happening? Let's do it again, then you will understand it. Let's suppose you got a mercury here, and mercury is this. Electrons are in different energy shells. Here, 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 here. Now, my question is, when you heated up the electrons through this cathode, okay, so basically, as soon as these electrons are passing through the mercury, what will happen? You provide energy to these electrons. When you provide
By
energy
heating.
by heating, absolutely. So they jump to new energy level, the very next higher energy level. But point is, can that be sustained for a very long period of time? No, it will not be. It will be unstable because that energy would not be enough for a very long period of time. So they jump back into the same energy level from where they actually excited. The point is, you provide them energy, they jumped into a new energy level by getting some amount of energy. When they jump back into the previous energy shell, what do you think? Will they release some amount of energy?
Yeah.
And that
So
energy
that's
will be
UV.
E is equal to H frequency. That is why, if you remember, I've told you this is called by Planck's constant. Now, still you can't see that light, right? But that phosphorus light, when electron hits that phosphorus coating, you will see a colored light which comes in your eyes. So as a result, visible light photons are released when electron returns to their original energy level, which provides the fluorescent glow. Do you understand that? Or any problem in this?
No, this is okay.
This
Wait,
is
can you
where,
repeat the last part again? The fluorescent.
okay, now I will read it and I will explain it again and again. No problem. Because this is the question which came in the examination. Fluorescence, now the fluorescence is a basically phenomena which occurs when electron in an atomic orbital absorb energy from an interaction with the photon or collision with another atom. First of all, remember that what is meant by fluorescence, because it calls a fluorescence tube. It only happens when electron absorb some amount of the photon which interact with it, or it can get that by using the collision. Now, fluorescent tubes are partially evacuated glass tube filled with low pressure mercury vapors with phosphorus coating on the glass. So here inside you got a mercury atoms as well as fluorescent coating on the screen. I mean these mirrors or whatever you have. When electric current is passed through the vapors, the electrons in the mercury are excited and move to the higher energy level. Because when electron passes through the mercury atom, what happened? Some of the energy is being given to the electrons in the mercury atom and they will be shifted to higher energy state. But remember that when they jump into higher energy state, it will no longer be that much stable. So they have to come back. So they jump back into the, what you call that, in the same energy level. And once they come back into the same energy level, definitely they have to release that amount of energy which actually came in previous. That energy can be given as E is equal to H frequency. Now, you want to see that energy. For that, a phosphorus coating is there with a mirror. When electron strike that mirror, that glass, you can see a fluorescent light, visible light photon. So that is how you've been seeing that light which can be visible. Okay. So this is the phenomena which I want you to write it along with the diagram. Because that came, the one you were asked me is that one actually. Okay, draw the diagram as the whole story is now important. Now, what is that photon model? This is actually related to the photon model. But what exactly it is? What I have just told you, the photons are fundamental particles which make up all the form of electromagnetic radiations, right? That's the first point.
Yes.
So basically, a photon is a massless packet of quantum of electromagnetic energy. And what it means that energy is not transferred continuously, but at a discrete packet of energy. It means now energy will be transferred in the form of discrete particle. Okay. So basically in pieces. Okay. So basically it will be discrete particles. So that's what the point is. In, in other words, each photon carries a specific amount of energy and transfer this energy all in one go. And that is equal to E is equal to HF. And now important thing, if you want to convert it into lambda, then the formula for the lambda, if you remember that, we had it, V is equal to
So,
frequency lambda. And that V of a light is C. And what is C? 3 into
uh,
10 raised to power
eight.
V,
Eight.
right? So now
Mm.
if you want to convert that frequency into somewhere velocity upon lambda, so you can write E is equal to HC upon. That is what we called as photon mode. So basically, now what is this H? H is a
Uh,
Planck's constant,
yes.
and the value is definitely there. That is what it is. I want you to write that as well. The equation tells us that the higher the frequency of electromagnetic radiation, the higher the energy of photon. The energy of photon is inversely proportional to the wavelength. A long wavelength photon of light has a lower energy than the shorter wavelength. It simply means that wavelength is inversely proportional to the energy. Now, once you understand the photon model and everything, now let's see a question which is very, very important in this case. Light of wavelength 490, I mean, light of a wavelength 490 in incident on a surface as shown in the diagram. So basically, as shown in the diagram, the power of a light is 3.6 milliwatts. The light is completely absorbed by the surface. Calculate the number of photon incident on the surface in 2 seconds. Now, how to do this? Let's write the data first. We will have the data 490 meters. Wavelength is given 490. Okay. What else is given? The power of
Eight.
photon is given 3.6 milliwatts. When you convert it into journal watts, it will be 3.6 into 10 raised to power minus 3 watts. And they say
Yeah.
completely absorbed from the surface. Calculate the number of photons, and the
They give the
time is given as 2 seconds. Now, this is the thing which is required. I mean, this is the thing which they are asking. Now, how many formulas we have done in this chapter till now? We have only done, I mean, we have only done this many formulas. E is equal to H frequency or E is equal to C over lambda. This is the formula we have done. We have done nothing but this formula.
Yes.
Okay. Now, important thing is this formula is for the one energy. I mean, if energy of one photon, remember that. So, what you do, find out the energy or power of proton. Now, how to convert this into power? Divide this formula by T because energy divided by T is a power.
E equal E over T.
So, E over T is power, which is equal to Hc upon lambda divided by T. Now, what is H? H value you do not remember, so I have to see that. What is H? H is 6.63. This one. And then
Yeah.
C is 3 into 10 to the power 8. Lambda is, what is it?
Or nine.
Uh,
No.
490 into 10 raised to the power minus 9. And time given as is 2. So what is it? Now important fact. Rather than going for the power because power is already given, the formula is technically E is equal to PT, I believe. I mean, the formula is, if you just check it out, you find out the inner power of light divided by energy. Okay, now another point, which is very, very important. Power is equal, okay, E is equal to PT. If you remember, this is the energy formula, we have it. Right? Now, when you have to find out the power of the light source divided by the energy of one photon, energy of one photon is, okay, multiply by the power. Energy of the light source. Why this is the case? Wait a minute. Calculate the number of in 2 seconds. Okay. Now, what is the power you had just got it?
Minus 19.
Now, what is exactly what into 10 to the power minus 90?
2.03 times 10 to the power minus 19. But
Minus.
the mark scheme is saying it's 4.06.
Wait, it's not yet done. Not yet. Just a second.
Okay.
Okay. Now, this is the power. Now, this formula is for what? This formula for the one. Remember that. This is for the one piece. And the power which is given to you is 3.6. What is it? Into milliwatts. So what you do now, this is highest. So you can say 3.6 into 10 to the power minus 3 divided by that power. 2.03 into 10 to the power minus 19. What is the answer for this?
Wait, why are we doing this?
To find out the number of, that thing.
A time.
Yeah.
That would in time.
Yeah, what is the answer? 3.6 into 10 to the power minus 3 divided by 2.03 into 10 to the power minus 19.
You get 1.77 times 10 to the power 16.
This is the answer. Now, what did I do? I explain it to you. You will understand. Let's check it out. First point is E is equal to HF, right? You tell me this formula, which is this one, E is equal, where is it? Sorry. E is equal to HF. This formula is for how many photons?
Um,
For one
One.
photon. Okay. So it means that whatever energy I will find out, it's for one photon, right? If I divide it by T, it will provide me energy for power for one photon. Am I right?
Right.
So what is the power for one photon? H is equal to 6.63 into 10 to the power minus 34. and C value will be equal to 3 into 10 to the power 8 divided by lambda, and lambda is given as 490 into 10 to the power minus 9. It gives me 4.06 into 10 to the power minus 19. This is not energy actually. This is energy. If I multiply it with 2 denominator, then how much it gives me in the power form? What is the power given?
Can you repeat that?
See, what did I do? I converted E is equal to H frequency formula into power formula. How did I did? I divided by the time. Energy divided by time and HF divided by time also.
Okay.
Oh, okay. Now if I try to find out the power of each photon in 2 seconds. So what is it?
Um, it is 4.06 times 10 to the power minus 19.
Minus 19. And the formula, and how much is it? The starting value?
4.06.
Mhm. Now, what is this power for? This power is for one photon.
So I got a 2.03.
Okay. Now, the power which is given to you is 3.6 into 10 to the power minus 3. Now, this is the power for multiple photons. So, what to do? How will you find the total photons? Divide the total power by a photon of one power, which is 4.06 into 10 to the power minus 19. Each photon has 4.6 into 10 to the power minus 19 value. How many photons? I mean, this power is for how much? So you divide it. Total power divided by power of each photon. What is the value coming up? 1.77 into 10 raised to power 16. So this is the number of photons.
Okay.
Understand?
Yes.
So I think we better finish our class here. Just go through that. Okay. In the next class, we will proceed further. And be on time, please, next time. All right.
Sorry.
Please. Thank you. See you.